All right, guys, I'm going to make a short video for you. A couple things where we ended in class. We were talking about if you were looking at a neon atom, specifically a neon 22 atom. The 22 represents the mass number. So you know here from the 10 that there's going to be 10 protons and 10 electrons. You take your mass number and subtract the number of protons, and it's going to give you 12 neutrons. So if you were looking at this atom, what you would have is you would have 10 protons and 10 neutrons in the nucleus, surrounded by a 1s orbital that would have two of those electrons in it. Then the 2s orbital, the next circle would have 2 electrons in it. Then you would have your dumbbell, your P-shaped we talked about in class. There's 3 of them, and each of those would have 2 electrons in it for a total of 10. 6, 2, and 2 make 10. And that's how your atom would look. But as you get more and more complicated, you're not going to draw this out for everyone. So in chemistry, we have a shorthand, which is called the electron configuration. And to do this, you use the periodic table. So neon, and you just follow the periodic table. Here's your 1s. So this one and this one are included in your 1s. So you're going to get 1s2. The next row is your 2s right here, 2s2. Then you're going to go to your P's over here. 1, 2, 3, 4, 5, 6. Neon ends here. So it's going to be 3p6. I'm sorry, 2p6. So you have 1s2, 2s2, 2p6. Then you would go down here if you were to continue on, but we've already gotten to the element that we want. So this is the electron configuration for neon, and you can double check it by making sure that it's the right number of electrons. 2 plus 2 plus 6 is 10, and that's correct. Okay, so the letters right here represent the orbitals that the electrons are in, your S and your P. The numbers up here represent how many electrons are in each orbital. Okay, and right here, the 1 and the 2 give you the energy level. Hopefully that makes sense to you. I want to talk about one more thing. So one thing that you need to know in the periodic table is this is going to be your 1s group right here, right? And helium is kind of accounted for over here. Then you have your 2s, your 2p, your 3s, your 3p, your 4s. This is actually the third level right here. This would be 3d. Then it's back to 4p. Okay, why is that? It's because the 3d orbital requires more energy than the 4s orbital, and that's why it's listed below, because that's the order of the energy that's required. So you do need to know how the orbitals fill up and what the order is, and it's going to be 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. Okay, and hopefully that makes sense to you. Let's do also I briefly mentioned this in class 2 when we were leaving, but this is why, because of electron configurations, this is why the periodic table is set up the way it is. This is your S block. This is your P block. This is your D block. This is going to be your F block, but in this class, we're not going to get into that, so you don't really need to know that. But this is why it's this wide here, this wide here, this wide here. It's because of how many electrons fill it up in the different orbitals. Okay? So let's do another example to make sure you guys understand. So now we're going to do the electron configuration for phosphorus. So what you're going to get for phosphorus is you're going to get 1s2, 2s2, 2p6, 3s2, and then it's going to be 3p1, 2, 3. And that's going to be your electron configuration. So it would look like this. 1s2, 2s2, 2p6, 3s2, 3p3. Okay, now let's try another one. Let's do silver. On your periodic table, the symbol is Ag, comes from the Latin word argenta. And on your periodic table, you'll see it right here. Okay, so let's do this configuration together and then I'll write it. So you're gonna get 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 5s2, 4d9. So if I were to write it, it's going to look like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So you just need to know the order that they fill up. 4p6, 5s2, 4d9. Okay? And you can count them up. Silver should have 47 electrons. And so to check, 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 9 should equal 47. And I know I didn't make a mistake. Okay. Well, it gets pretty tiring to write out this, even though it's a shorthand, it gets pretty tiring to write it out this way. So they even have an abbreviated way to write your electron configurations. And the way to do that is you look at group 8A on the periodic table, which is right here. And chemists identify the behavior of all atoms based on how far away they are from this column, okay? So to abbreviate an electron configuration, you need to look at the nearest atom in 8A that has a lower atomic number than the one you're working with, not higher. So if I was working with bromine, even though right here krypton is closer, I can't look at that one because it's higher. I need to go to the one in 8A with the lower, so I have to go all the way back here to argon. Okay? And we start with that, and that's how we do our abbreviation. So if I were looking at, let's see, strontium, for example, right here we have strontium, which is SR. So if I wanted to do the abbreviated form, I would put in parentheses, in these brackets, the one in 8A that's the closest but lower. So strontium's here, so I have to go over here and it's gonna be krypton, okay? So KR is gonna be what I'm abbreviating. And then I put the rest of what it would be. So I don't have to go through all the way up to KR. I take the bracketed KR, and then to get to strontium, it's just 5s2. And that is my abbreviated form, instead of having to write it all out. Let's try another one. Let's do selenium. Okay, if I wanted to do selenium, let me show you where that is on the periodic table. Selenium is right here on the periodic table. So I need to go to the one in 8A that has the lower atomic number. So that's going to be right here, argon. So that's the one I'm going to put in bracket. And then I continue on until I get to selenium. Okay, so right here. And then I'm going to go right here. And it's going to be 4s2, 3d10, 4p, 1, 2, 3, 4. And that's going to be my abbreviated form. 4s2, 3d10, 4p4. All right, hopefully this makes sense, electron configurations for you. This kind of ends the chapter. Let me take a look at your test and see if I can give you any hints. Okay, some hints for your test. You do need to understand electrons, protons, and neutrons, what those are, where they are at. I gave a lot of history in the lecture before last. You do need to understand a basic amount of that history, like a basic, who did what experiment, what did that show, that kind of thing. Remember, you need to know about wavelengths, longer, shorter, things like that. You're going to need to know about amplitude, all the stuff we just talked about in class yesterday. And then you need to be able to give me electron configurations, both the full electron configuration like I just showed and abbreviated electron configurations. Also, I should be able to give you an electron configuration and you tell me what element that is. Okay? Let me know if you have any questions. Good luck on your test, and I'll see you guys on Monday.